Okay, hello. Um, this is my code. So we're literally just opening two images, and then we're grabbing the width and height from our original image, and then we're grabbing the pixels from both images. I think, yeah. And then I have different variables for the width and height of my two different images. Um, and then this doesn't even do anything right now with my code. This is a test. Okay, where are we at? So we're creating a new image, and then we're loading the pixels on that new image so that we can actually add to them. Okay, for X and Y, we loop through the whole image. We grab the RGB values from every single pixel as we loop through them. And this is the meat of the code right here, literally just checking. This just took some tuning to figure out what values would accurately grab the image. So if the green value is less than or greater than 140, red is less than 110, and blue is less than 130, that means that we are going to set our new pixels, whatever that original photo is. We want those. Otherwise, we're saying that that is not a green pixel on our green screen image, and we want those images on our new photo. So we're going to grab pixels from the top and set them on our new. So that means our new photo has both the background of the original and the top pixels of the new. And this is just iterating through the loop, and then we're showing it. Cool. And then I can run that. Have the cat image in the sunset doing that right now, so you can see it's doing that, and then I could swap this out. I was testing it with the space shuttle. That looks decent too. Some little fragments there, and I think I could continue tweaking it, but I think it looks okay. And then to go above and beyond, I decided to try pixel sorting. So using Pillow. I got this idea because my brother did the same thing. He did it in Go. So I downloaded his and ran it. See if I can run that. Here's his. Find. Sorry. Alright. And it produced this from this Earth image. And his has lots of options. You can make it look cooler than this. I think right now it's literally just sorting row by row, which is what I decided to do. So here's my pixel sorter. It's pretty cool. I followed a tutorial, but I was surprised by the number of things that I understood. There wasn't like a lot of new code that I had to look up or understand. It was pretty simple Python, like 39, 38 lines of code. So I literally just open an image, I grab the pixels, grab the width height, which I reference a lot in here. We iterate through every Y value, so we're going down the image. We're setting this array row, and then we're running from left to right on our X value, and we're adding each pixel to our row array. And then what we're doing is we're sorting that row of pixels that we now have. So what this does here, it calls this function sort row. Sort row it's very simple. We just have these values which we use for the math sorting. We run through the entire length row of the array. We create this temporary value which holds the brightness of any one pixel I, right, index I, because what we're inputting here, row, is actually an array of pixels, and each pixel is at index 0, 1, and 2, it's red, green, blue. Anyway, so once we add those all up, we get the brightness of that pixel. What we want is the darkest pixel on the row, and we're going to sort those pixels up to that point. So we create this temporary value. If it's less than our max brightness, 255 times 3, we are going to make that the new pixel that we care about. And once it runs through, it's going to find the darkest pixel. What we care about is the index of that pixel, I. We set that here, min index. And then what we want to output is that row of pixels all together. So we have this variable sorted row. We're going to grab row up to, we're going to splice it, or whatever you call it, slice it, which is what this colon does. That's one of the things I had to look up to min index I. right? And then it's going to sort that array from smallest to greatest with literally just the built-in sort function on Python. And then we're going to return that value, or that array sorted up to the darkest pixel, plus the rest of that array of, or the rest of the pixels, because we can't just have the pixels up to the darkest. We want the whole line of pixels, which is done here. Okay, so we've returned that, and now we've sorted a row, and then we're literally just going to do that for every row going down the image, and we're going to replace the original pixels with that row of pixels. And so we have our new image. We create our new image, and we're going to add those pixels that we've made running in this loop XY. We're going to add those pixels to something called sorted pixels. And then this is also new. A function called put data is going to take that array of pixels that we made, and it's going to shove them, or that list of pixels that we made, and it's going to shove them in our new image, and then we're just showing our image. So I can run it, and it does this. So it's just a picture of a rock in the snow. You can see this is apparently the darkest pixel in that row, and it's going to sort all the pixels up until that point, and then we have the rest of the row of pixels. And it looks cooler on different images. Obviously not high tier art. It's one of the green screen images. It has some cool effects. It can look cool. This is a very big image. You can see just how many pixels there are to be sorted, but I think it looks pretty cool. Anyway, that is that.